Hey everybody, welcome back. This is yet another lab walkthrough video. This lab is forming covalent compounds. So again, like always, you have a bunch of useful background information, and all this information is going to be used to answer the background question. So the first set is talking about what elements are involved in each of the three bonds. Next question is what happens to the electrons in each bond, and then diving deeper into how many pairs of electrons and number of electrons are shared in the different types of covalent bonds. So again, all this info comes right from that short little paragraph. This is a great summary chart for all of this information. So our goal for this lab is to show how covalent bonds are formed with the sharing of electrons. So what you're going to do is work through different examples to literally share electrons. So when you're doing this, your first step is to draw the dot diagram of all the atoms involved. So you'll have whatever compound it is. H has 1 valence electron, you draw 1. F has 7, you draw 7. Now the whole point of a covalent bond is to have electrons being shared. And so a lonely electron of one element is going to pair or be shared with the lonely electron of another element. So right now, we can see that those two electrons from H and F are going to be shared. And so if you do a little manipulating, you get these two shared electrons. One of them comes from H, one of them came from F, but together they have full valence shells. Now with this, just to make sure that you've created your compound correctly, we have these questions. So how many valence electrons can hydrogen hold in its valence shell? That max number is 2. Fluorine's max number, as in most elements, are 8. So if we take a closer look at our picture, either this dot diagram or what looks more similar to what you'll be creating, if you look at hydrogen, hydrogen has 2 electrons. It can only hold 2, it is happy. Where if we look at fluorine, fluorine has all 8. So we know that after the electrons are shared, both elements, yes, do have that full valence shell. So if you try to transfer an electron from one to the other, kind of like with ionic, you'll see very quickly that both elements will not be happy. So at your station, you'll have an envelope of these different atoms. So chances are you may have seen these before. And so I want to work through the model with you. The model requires H and F. So the first step is to draw the dot structures of the atoms that are involved. So H has 1 valence electron, H with 1 dot. Fluorine has 7 valence electrons, so you draw the atom like that. So now when a covalent bond happens, electrons have to be shared. So hydrogen has 1 lonely electron and 1 empty space. Fluorine has 1 lonely electron and 1 empty space. And so what's going to happen is that they're going to kind of share those two and covalently bond. So in the model, you have the 2 lonely electrons sharing. So you're going to use these models to kind of mimic that as well. So you're going to need to unhook the fasteners. And so one of these, put them overlay each other. One fastener goes in, one fastener goes in. So now if you look at it, hydrogen can only have a maximum of 2 valence electrons in its outermost shell. At this point, it has that. It's stable. It's happy. Fluorine has a maximum of 8 valence electrons. Now that has all of its 8. So that is your stable covalent bond. The electrons are being shared. So then when it asks you to draw your dot diagram, you're essentially drawing what you've seen here. You have this shared pair, and then you have all the other lone pairs around fluorine. So now, at this point, it tells you what compounds you need to make. You need to take out 2 H's, 3 Cl's, and 1 oxygen atom from your folder. And once you do that, you'll have 3 compounds to be making. Doing the same thing for each of the compounds. So HCl, Cl2, and H2O. H2O can be a tiny bit tricky, but I have faith in you that you can do it. Now, at this point, everything needs to go away before you even finish talking about the other questions. Now, these two questions, based on what you know about chemistry and also based on the background information, you should be able to compare the relative strength of covalent bonds compared to other bonds and talk about why covalent bonds are poor conductors. That is your lab. Have fun.